studied about the continuity, its definition. We have seen few sums, few illustrations to understand continuity. Now we continue with the continuity with an example. The example is the function defined by fx equals to mod x a continuous function? The previous sum we have done the same sum, fx equals to mod x and x equals to 0. But now here it is said that continuous, is it a continuous function? We have to find out, and it is not mentioned at particular point. So we have to check for all. Now let fx equals to, when I remove this modulus, we get the value minus x when x is less than 0 and x when x is greater or equal to 0. Now we have to check for all the real numbers. Now let c be a real number such that c is less than 0. C is less than 0. Now let us check for all real numbers less than 0, whether it is continuous or not. So for c less than 0, we find out fx. Fx will be minus x. Now at f of c, it is minus c. So at c, at real number c, the value is minus c. Now let us find out the limit. Limit x tends to c of x equals to limit x tends to c and value is minus x. The function fx is minus x. Replacing the value, I get as minus c. So therefore f of x equals to limit x tends to c of x. That is, now this function becomes continuous at real value c less than 0. Therefore we can write f is continuous at c less than 0. C is real. Now for real number c less than 0 we have done. Now for c greater than 0, let us check. If c is greater than 0 and c is real, then my fx will be, when x is greater than 0, fx will be x. Taking the value at c, so f of c is c. Now I find out the limit. Limit x tends to c fx equals to limit x tends to c and the value of fx is x. So answer is c. Therefore f of x, that is limit x tends to c fx equals to f of c. So as limit and the value of the function are same, then we can say f is continuous on c, where c is greater than 0 and is real. Now further, to get more idea of equal to 0 also, we have to solve in a similar manner as we have done earlier. So for that also we can do it, but I think you have understood that particular sum, so I leave it to you. Take the help of that previous sum of fx equals to mod x at x equals to 0 and complete it. That will help you to understand this particular continuity more clearly. One more sum to understand continuity. Question is, discuss the continuity of the function f given by fx equals to x cube plus x square minus 1. Now here x cube plus x square minus 1 is a polynomial function, and these polynomial functions are normally continuous. So To solve this, we take four real numbers for every real number, say C. We try to find out the continuity for every real number C. Now, f of x is equals to x cubed plus x squared minus 1. So f of C, when I put the value of x as C, I get c cubed plus c squared minus 1. Now when I find the limit, it should be equal to f of c. If it is there, then it is continuous. Let us check the limit. Now, limit x tends to c, f of x equals to limit x tends to c, x cubed plus x squared minus 1. Now replacing the value of c in the limit, we get c cubed plus c squared minus 1. So this value and the value of f of c are same. Therefore, I can say that f of c is equals to limit x tends to c fx. So as f of c and limit are equal, the function is continuous. Therefore, f is continuous on any real number c. Now another example to understand continuity. Discuss the continuity of the function f defined by fx equals to 1 upon x. X is not equal to 0. Now let us check this whether it is continuous or not. For that, let us take, let c be a non-zero number. Non-zero number means c is not equal to 0. Right? And on that number, we try to check and get the answer. Because we know that in denominator we normally don't write 0 because we don't get the answer. So we check in c. So c is not a 0 number. Now, f of x is equals to 1 upon x. Therefore, f of c, if I put, it is 1 upon c. Here, c is not 0. Right? So this is the value of my function fx. Now I find out the limit. Limit x tends to c, f of x equals to limit x tends to c, f of x is 1 upon x. Now replacing the value, I get 1 upon c. Here again, c is not 0. Therefore, value of the function and the limit are same. Therefore, I can say limit x tends to c fx is equals to f of c. When it is equal, the function is continuous. Therefore, f is continuous function when c is not 0. Right? The previous sum led us to the concept of infinity. Let us try to understand the concept of infinity using the function fx equals to 1 upon x when x is very near to 0. I am not saying it is 0, very near to 0. Now very near to 0, what does that mean? Your function fx equals to 1 upon x. I take the value of x very near to 0. Let us say x and fx. I try to find out different values at x and fx. First I take 1. If I take 1, the value of fx, so f of x equals to 1 upon 1, I get 1. So my answer is 1. Now I take another value, say 0.3. I am going towards 0. 0.3. So the value of x is 0.3. So f of x equals to 1 upon 0.3. What will be the answer? It becomes 10 upon 3 gives me 0.5 3, 3, 3, and so on. Correct? Sorry, it is 3.33, not 0.3. So it is 3.33 and so on. Now I take another value, say 0.2. 0.2. What we are doing actually, if I make you understand with the help of number line, say 0 is here, 1 is here. From 1, I am coming towards 0. So different values at 1 I am taking on the number line very near to 0. And I will be reaching very near to 0 and try to get the answer. Now 0.2 if I take, what answer I get? 0.2. So f of x equals to 1 upon 0.2, that is, if I remove decimal, it is 10 upon 2 gives me 5. So answer is 5. Next value I take very near to 0, say 0.1. Now what I get? If I take 0.1, f of x equals to 1 upon 0.1, that is 10 upon 1 means 10. I get 10. So when I am going very near to 0, my value is increasing, as you can see. Further, I take 0.01, which can be written as 10 raised to minus 2. Right? 10 raised to minus 2. Now f of x equals to 1 upon 0.01. It is 100 upon 1. Gives me 100. So answer is 100. Further, 0.001, that is 10 raised to minus 3. It will be 1000. And if I write 10 raised to minus 4, it will be 10,000. Right? So as I am approaching very near to 0, this value is decreasing, reaching very near to 0. My value is, the value of the function keeps on increasing. Now, if I find the limit x tends to, say, 0, very near to 0, f of x, that is, limit x tends to 0, 1 upon x, the answer turns out to be infinite. That is, infinity. So this is from positive side. So I write plus infinity. Now it is not a number. It is not a real number. We cannot say it as a real number. If it is a real number, then we get a function and the continuity also. But this is not a number. So I am getting a value, but this function is not continuous at x equals to 0. We have got plus infinity is not a real number. Therefore, f is not continuous at x equals to 0. So I am talking about continuity also and trying to explain the infinity also. So it is not a continuous function, keep in mind. Don't say that it is continuous because we have got a value. It is not a value, it is for understanding the concept of infinity, how we will reach infinite. This is on positive side. If we take it on negative side, if the values are minus 1, minus 0.3, minus 0.2, you will get all negative values. So when I take negative, so this is 0 plus limit x tends to 0 minus fx. So limit x tends to 0 minus 1 upon x, I will get minus infinite. So this is how we will be getting plus infinity and minus infinity, but they are not the real number. And the function remains discontinuous at x equals to 0. So it is not a continuous function at x equals to 0. Now discuss the continuity of the function defined by fx equals to x plus 2 if x is less or equal to 1 and fx equals to x minus 2 if x is greater than 1. Now this function is defined on every real number. So let us solve and get the answer whether it is continuous or not. Now for every real number, say C is real number. Now if C is less than 1, then my function C is less than 1, x is less than 1, my function should be this. Therefore, f of x equals to x plus 2. Now at C, f of C, I find out it is C plus 2. So the value of fc is C plus 2. Now we find out the limit when x tends to C. Limit x tends to C fx equals to limit x tends to C. The value of fx is x plus 2. So my answer is C plus 2. So value of the function and the value of the limit are same. So f is continuous. Therefore, limit x tends to C fx is equals to f of C. Therefore, f is continuous function when C is less than 1 and C is real. So one part I have checked. Another part, now when C is greater than 1, if C is greater than 1 and C is real, what happens? Let us see. If C is greater than 1, my function f of x greater than 1, this is greater than 1, my function should be fx equals to x minus 2. X minus 2. Now the value of this function at C, so f of C equals to C minus 2. So this is the value of the function. Now the limit. Limit x tends to C of x equals to limit x tends to C. The value of fx is x minus 2, which is C minus 2. Again the values are same, so it is continuous. Therefore, limit x tends to C fx is equals to f of C. Therefore, f is continuous on C greater than 0, C greater than 1, and C is real. Now if it is at 1, then what happens? Here we have taken greater than 1, less than 1. Now we take C equals to 1. If C is equal to 1, then what happens? When C is equals to 1, I cannot directly write that it is x plus 2 or x minus 2. So I have to take plus 1 and minus 1. So at C equals to 1, I want to find out. So limit x tends to C minus fx. That will be equals to limit x tends to C minus. C minus means it is less than 1. So less than 1 means x plus 2. So my function is x plus 2. So when I put the value, it becomes C plus 2, which will be equals to f of C. Now, limit x tends to C plus. What will be the value of fx? Limit x tends to C plus. Now when I write C plus, it is greater than 1. Greater than 1 answer is x minus 2. So it is x minus 2 gives me C minus 2. This value, when we find out at particular value, it is equals to f of C. But when we find out left and right limit, now we check limit x tends to c minus fx and limit x tends to c plus fx. So c plus is c minus 2 answer and c minus is c plus 2. So both the limits values are different. So here this function is not continuous when x is equals to 1. Therefore f is not continuous at x equals to 1. Or you can write down f is discontinuous at x equals to 1. So this function is continuous when x is less than 1, greater than 1, but when x is equals to 1, it is discontinuous. Now another example. Discuss the continuity of the function defined by fx equals to x plus 2 if x is less than 0, minus x plus 2 if x is greater than 0. Here the function is defined except at 0. That is, at 0 it is not been given, but other than 0, less than 0 and greater than 0, the function is defined. And it is also not said that whether the x is real number or not. Let us take it as real number. Let c be a real number. Okay? We are taking on a real number. First, let if c is less than 0, then let us find out what happens. Fx will be x plus 2 when it is less than 0. Therefore, f of c will be c plus 2. Now we find out the limit. Limit x tends to c fx equals to limit x tends to c, it is x plus 2 gives me c plus 2. Therefore, f is continuous at c less than 0 and c is real. C is real. Now we find out on greater than 0. If c is greater than 0, c is real number. So fx, when it is greater than 0 means this value. So fx is minus x plus 2. When fx is minus x plus 2, we find out the value at c. F of c equals to minus c plus 2. So this is the value of f of c. Now the limit x tends to c fx equals to limit x tends to c minus x plus 2, which is equals to minus c plus 2. F of c and limit are same. Therefore, limit x tends to c f of x is equals to f of c. Therefore, f is continuous at c greater than 0. C is real. Now to understand it more clearly, let us draw a graph also to understand it. X-axis, y-axis, so 1, 2, 3, minus 1, minus 2, minus 1, 2, 3. Now when we draw the graph, the value, if I take x as 1, so answer is 3. Answer is 3. Correct? When I take x as here, x as 1, answer is 1. So different answer we get. Now when we draw the graph of this, the graph will look like this. It will pass from, so we won't be getting this particular value. This value I am keeping it open, and it will pass from 2 minus 2, and here it will pass from 2. So this will be the different values when we take, correct? So if x is 0, we don't have any value, correct? When x is not defined at 0, means we can say this particular function is discontinuous at x equals to 0. Therefore, f is discontinuous at x equals to 0 because it is not defined. Here also the function is not defined. X is less than 0 is defined and greater than 0 is defined. So f is discontinuous at x equals to 0. Other than that, you have the value. So from this portion it is continuous, here also it is continuous, but at a particular point it is discontinuous. So when I draw the graph, I have to lift my pen here, then I continue. So this becomes discontinuous at x equals to 0. Now, if you have understood everything, the thing which I am teaching you for continuity and the concept of continuity, if you are understanding it from these videos, then please like the video, press the thumb up button and subscribe to the channel. You also press the bell icon, you will get the notification. Thank you for watching.